All right, just showing what's in the classroom. We also see posters for my career development class that's posted here, which career development is up in December, so I'm done with career development. And then we have our classroom rules that's posted. And then we have bell work trays. This is where I keep all of my bell work. The students have each week, they have a bell work packet. So they work a sheet a day. And they get 1 grade at the end of the week for their bell work packs as they complete them. Okay, well, let's get started for today. We're going to take a look at bell work for this morning. This is a lesson 19 cool down. As we move into lesson 21, we're going to look at this cool down for our bell work shortly. So as we look at this, seeking solutions, we have a solution here. Which graph correctly shows the solution to the inequality? So we have the inequality here. Which is in fraction form, but we're not afraid of fractions, right?
No.
We're not afraid of fractions. So can somebody tell me, what do we need to do first to solve this inequality? What do we need to do first? David?
Multiply by 9.
Multiply everything by 9. That's what I would do. So we have 7x minus 3 over 9 greater than or equal to 8 minus 2x. So David said multiply everything by 9, which is the correct answer. Good job. Can somebody tell me what we get from that? If we multiply everything by 9, what happens to this?
It cancels.
These cancel, okay? So that leaves me with 7x minus 3 is greater than or equal to, let's do our multiplication. What do we have? 9 times 8? 72. And then 9 times negative 2x?
Negative 18.
Negative 18x, okay? What do I do next? I'm working on getting the x's together. So we want to add 18x, very good. Add 18x. So 7x plus 18 gives me 25x. Greater than or equal to. And then we negative 18x plus 18x cancels. Okay? So now we're left with 72. And, oh, we forgot the negative 3. Sorry. Imperfections. All right. 25x minus 3. Okay, now what do we do next?
Add 3.
Add 3 on both sides. So that leaves me with 25x. This cancels. It's greater than or equal to 75. Very good. What's my last step?
Divide by 25.
Divide by 25. Divide by 25. This cancels. So we're left with x is equal to,
3.
not equal to, greater than or equal to 3. Now, as we solve this inequality, can someone tell me which would be the correct answer? Lily. So C. So Lily says C. So as we look at previous learning, we highlighted that if we have a greater than sign, which direction do we go?
Right.
We always go to the right. Now here's the key as to if the circle is going to be filled in or not. What do we look for? Equal to. So if we have an equal to sign, then our circle will be filled in. So we see that the circle's filled in, we're on 3, and we're going to the right. So this C would satisfy that particular equation. Good job, everybody. Now, let's go to our textbooks to lesson 21. lesson 21, again, the title of lesson 21 is Graphing Linear Inequalities in Two Variables. Graphing linear inequalities in two variables. So let's look at our learning targets for today. Our learning target today is let's find out how to use graphs to represent solutions to inequalities in two variables. Inequalities in two variables. Prior learning, our last lesson, we highlighted one variable. Okay? Now we're moving to a situation where it involves two variables, okay? So let's go to our first exercise, math talk. Less than, equal to, or more than 12. Let's take a look at our first problem. Here is an expression, 2x plus 3y. So we notice first off, we have two variables, don't we? Two variables, x and y. Okay? Decide if the values in each ordered pair, x, y, make the value of the expression less than, greater than, or equal to 12. Less than, greater than, or equal to 12. All right, so let's take a look at our first one. This is our first order pair, 0, 5. So first of all, what are we doing here? We're plugging the x and y. So in our order pair, our first number is always our x, and our second represents our y. So can somebody tell me what our expression is going to look like if we plug those numbers in? Madison?
2, 0 plus 3 times 5.
Everybody agree to that?
Yes.
All right. So now let's put in this, let's do our math here. 2 times 0 is 0. 3 times 5 is 15. So we have 15. What is that pertaining to 12? Is it greater than 12? Yes, it's greater than 12, so we can put a G here. All right, very good. Now let's go to our next order pair. Order pair 6, 0. So what will be my setup for 6, 0? Anybody tell me? Lily? Very good. Everybody agree to that?
Yes.
All right. So we do our math. 2 times 6 is 12. Okay. 3 times 0 is
0.
So we have 12. Greater than, equal to, or less than?
Equal to.
Equal to. I've done 2. You do the next. Let's put an E there. That's our next two order pairs. Very good. Good job. Okay, so let's take a look at the third order pair. Spencer, what do we look like for our third order pair?
Times 2 by negative 1.
2 times negative 1
And then you
plus 3, 3
times negative 1.
times negative 1. Okay? And so,
You get negative 5.
so negative 2 minus 3 gives us a negative 5. So what's my answer? Less than. I'll put a nice little L there. Don't make fun of my L. Don't make fun of it, okay? Who's my make fun of about my L's? Can't remember who it is. 8, oh, yeah, that's right, 8 is not here. All right. So who would like to do the next one? Thomas? What do we have?
2 times negative 5
All right, 2 times negative 5.
plus 10 times negative, wait.
3.
3 times negative 10, 10.
3 times 10. All right. We can always trust Thomas again. All right, 2 times -5, -10 plus 30. What's our answer? -10 plus 30 gives us a
20.
whole 20. 20. So, all right, so a positive 20, so what does that mean? Greater than. Great job, guys.
Yes.
Let's go to our next exercise. Keep in mind, again, our learning goal, before we move on, what was our learning goal? Find out how to use graphs to represent solutions to inequalities in 2 variables. All right, so let's move on. As we look at this inequality, 2 variables, we see clearly. Identify 3 coordinate pairs that are solutions and 3 pairs that are not solutions to the inequality. What do you notice about the plotted points? So if we look at this particular activity, looking at 3 coordinate pairs, what could we use? What do you think?
Y equals mx plus b.
Y is equal to mx plus b. Okay. How does y equal to mx plus b help me? Slope-intercept form. Okay. So what's going to be my answer if we do this? So if we have 2x plus 3y is less than or equal to 12, then if I do this, we're going to have 3y less than or equal to -2x plus 12. Okay, what do I do next? I need y by itself. Thomas?
Divide y by 3, and then divide -2 by 3, and 12 by 3.
Very good, thank you. So that leaves us with y is greater than or equal to -2x over 3 plus 4. All right. So now we have it in y equal to mx plus b format. So now that we have it in y is equal to mx plus b format, what can we do next?
Plot.
We can plot points. Let's plot points. How do we plot points? Let me put this here on this side. It's in the way of the graph.
Find your y-intercept.
All right, so Madison, you said the first thing, look at the y-intercept, which I would agree with. All right, so we're at +4. +4 is here. Now, what do we use? Slope. Rise over run. Very good. So what do we want to do? We want to go down to over 3. 1, 2, 3. Down 2 over 3. Down 2 over 3. Now, interesting to note, we were going down. Can I go up?
Yes.
If I go up, what do I have to do though with the number?
Swap. Flip the sign.
Very good. So I can go up 2 over 3 to the left. Up 2 over 3 to the left. Now, we got plenty of points here. So let's identify some coordinate pairs. Somebody give me some coordinate pairs? Madison?
3, 2.
So we have 3, 2. Good, that's one. What about another one? Jason? 0, 4. Y-intercept, good. Next. Alexa? -3, 6. That's good. Okay, so that satisfies that point. 3 coordinate pairs that are solutions. Now let's draw a line here. Interesting to note. We're going to talk about it a little bit later. But when we look at this sign, less than or equal to, then what are we looking for when it comes to less than? When we talk about in terms of the line, let's make a line. My line's not going to be beautiful. All right, let's make one anyway.
Oh, that's wicked already.
That's terrible, isn't it?
That's terrible.
That's an ugly line, but we're gonna survive. We'll survive.
Maybe.
Now, it mentions here coordinate pairs that are solutions and three pairs that are not solutions. How do we know which ones are solutions and which ones are not solutions? So it's less than, so where are we gonna shade?
Down.
Down.
We're shading down, right? We're gonna shade down. All right? Let me make my grass. Or as Chelsea says, my straight hairs on my head.
What happened? What happened?
Seem to have one.
You must have had your beard.
Yeah, my beard. All right. Now I'm shaded underneath the line. So again, let's highlight that again. If we shaded underneath the line, what is that? What, in terms of my solutions, do I have solutions here or here? Below the line, because it mentions in our y is equal to mx plus b format, y is less than or equal to negative 2 over 3 x plus 4. Very good. So, again, let's highlight some solutions again. If they're in this area, did we pinpoint solutions that's in this area? No, we didn't. We have one here. Go ahead, Alexa.
So, do the ones on the line count too?
Okay, do the ones on line count too? How do we know that?
Cause it's
So straight
it's less than.
No.
If it's a solid line.
There we go. Equal to means what type of line we're gonna have?
Solid line.
Solid line. And if it's equal to, that means that the solution is
It's included.
included. It's included, right?
Mhm.
If we have a dashed line, then the solution is not included. So we can clearly see that this line is solid because of the equal to sign. So therefore, we can use solutions that's on the line. So take for instance, JC's ordered pair, 0, 4, would that be a solution? Yes. What about, who gave me 3, 2? Madison? Is Madison's solution on the line? Or is it in the area? It's on the line, so that's a solution. All right, negative 3, 6, who gave that to me? Thomas? Alexa gave that to us. Is that in the area of solutions? Negative 3, 6? It's on the line. So we have 3 solutions. So somebody give me 3 solutions that's 3 ordered pairs that's not a solution to this. Lexi? 8, 6. Does everybody agree to that? 8, 6, looks good. Okay. Chelsea? 8, 8. I like that. And Jason? 6, 7. 6, 7. Looks good to me. Y'all on a roll. Now, the last question says, what do you notice about the plotted points? The plotted points, they're on the what? They're on the line. And being on the line, as we talked about with Alexa, it makes it a solution because of this very point. Equal to. All right. Any questions about that?
No.
All right, let's move on. Here are 4 inequalities. Study each inequality assigned to your group. So it's time for us to work together. All right, assign to your group and work with your group. As we look at these points, we're gonna find some coordinate pairs that represent solutions to the inequality, as we just did in the previous portion, and some coordinate pairs that do not represent the solutions. Plot both sets of points, either use 2 different colors or 2 different symbols like X and a 0 or O. All right, so as we look at this, I'm gonna give you each table a graph. So let's start with table 6, X plus Y is greater than 10, okay? Table 5, 3X is less than 0. Table 4, negative 2Y is greater than -4, and table number 2, the first one, x is greater than or equal to y. So each of you work on those particular graphs, and let's see what we come up with.
And there's no slope.
See, in my humble opinion, we subtract the x from this side. And then we get negative x plus 10. When you get negative x plus 10, you see that 10 plus 10.
So we're just gonna write, draw that on the graph, and then line through
Okay,
2, and then
You're
under it.
Good job, Thomas.
good. Yeah. Okay, so we have 3x is less. 3x is less than 0. Okay, so if you, again, set that up. Oh, yes, ma'am? 1 second.
Okay.
We're gonna get to you in a few minutes. Okay, so you pointing here to this direction, right? Set it up as x is less than 0, okay, which is good. So as you go to this direction here, again, less than means what direction? You're going to the left, and that's what you clearly have right here. You're moving to the left, and then you notice your line. Your line is showing here on the y-axis, but you're moving to the left there, so that's good. And then Cheyenne. So silly.
It's not good.
All right. Okay, very good. You shaded well.
Yep.
Shaded well. You have the first equation. Okay. Shading down because it's less than. Okay. How about we do this? Let's look at the first graph, and I assign table 2 for that first graph. Thomas, you want to come up and show us the first graph, what it should look like? Feel free to take your textbook with you if you like. Feel free. Don't fall out. You can do it, Thomas.
Come on, Thomas. You got this, Thomas.
Oh, here's a marker.
No marker.
Sorry, you did a marker, right? All right.
So it says x is greater than or equal to y. This also means 1x, which means it is 1 over 1. So you can't really put it on 1 because that's not how it works. You have to put it on the origin. And since y also is equal to 1 over 1, you go up 1 and to the right 1. So that would be your y. And going down 1 and to the left 1, this would end up how you do it. And since x is greater than, shade down.
Does everybody agree to that?
Yep.
I agree. And then just look at it. Look at that equation. X is greater than or equal to y. Is it already a y is equal to m supposed to be format? Technically it is. Right, it is. I mean, it's a backwards, but it is. So, and you have your slope 1 over 1. That's implied. So very good, Thomas. All right, so table 2 at -2y greater than. So Lily, can you explain the graph for this particular equation?
Okay, so there's not an x, which means there's no slope. So it's gonna be a straight line, but we have to get y by itself. So we're gonna divide by -2. So we have y, and since we're divided by negative, we have to swap the side. So we're gonna have y is less than 2. And so then we're gonna, put our point at 2. And it's just gonna be a straight dotted line, because it's not equal to. and then you just shade over.
Very good. I like that because of the fact that you notice that there's no slope. Well, we have 0 for the slope. Let me change that. I want to say no slope. Slope is 0, okay? So if slope is 0 and you're on the Y, you're using Y, so we know we're gonna use the Y-axis, and we're right here, dotted line, so perfect. Good job. We're 2 for 2. All right. What's my next name? 3x is less than 0. Abigail.
Oh, no,
How's my friend Abigail doing today?
terrible. I'm not gonna.
All right. Who likes to do this? Go ahead, Alexa. 3x is less than 0.
Okay,
How will you tackle that?
so you wanna get your x by itself, so you're gonna divide by 3, and since you do it on one side, you do it to the other side, which is still gonna be 0. So x is less than 0. So the y-intercept is gonna be on the 0, like through the, not through the origin. And it's gonna be a dotted line, since there's no equal to. And since it's going to the, since it's less than, you're going to shade to the left.
Perfect. Everybody agree to that? Yes, good job. Y'all are very clear and have a good understanding of how these inequalities work. Because of the fact that our prior learning and other lessons, we really highlighted, again, less than, equal to, less than or equal to, greater than or equal to, what these mean. We used, last time for our lesson, we used number lines, didn't we? We had number lines, and then that gave us the understanding that we have now of how this works. Again, understanding that greater than means we're going to the right, less than, we're going to the left, and we highlighted how the less than, if we have equal to, then our line is always gonna be solid line. If it doesn't have the equal to, it's gonna be a dotted line. Good job. Let's look at our last one. Who would like to be a brave soul and take care of our last one at table 6? Anybody? Any takers? Come on up, JC.
Okay,
All right, thank you, ma'am.
so we're gonna put it into y is greater than mx plus b1, so we're gonna subtract x both sides. So our slope is negative x and our y-intercept is 10, so we're gonna put 1 at 10, and we're gonna go down 1 over 4. And the line's gonna be dotted because it's not equal to. And since y is greater than, we're gonna shade by.
What do you think, my friends?
Yes.
I think that's great. Excellent. Give her a hand. Now, what if this y, what if that y had a negative on it? What would happen?
That would become a negative.
What would happen to that? What would happen to this?
It would flip.
It would have flipped. Yeah. Always remember, sometimes students make mistakes. And when you're dividing by a negative, always make sure to do what? Flip your sign when you divide by a negative. You always want to do that. All right. Next. Those are our solutions to what we just did. We can verify that. Everything looks good. Everybody did a great job with that. Now let's look at these particular problems here. Are the points below solutions to either of the inequalities? Are the points below solutions to either of the inequalities? The question does not come out right out of my mouth. And it doesn't sound right. I think we're missing a word here. Okay. So x is greater than or equal to y. Okay. X is here. Y is here. What do you think? X is 5. Y is 4. Or do we have to look at more?
I think it works at both.
What do you think? You think it works? I think that works. Yeah. Long as you look at your X and look at your Y. So give me the answers to these. Who can give me number one? Is X greater than or equal to Y?
Yes, sir.
Yes. What about this?
Yes.
Yes?
Only for one.
Will this apply?
Yes.
Now let's go to this side. Now let's use our reasoning with this. X is greater than Y?
Yes.
Yes.
Yes. X is it greater than Y?
Yes.
What about this?
No.
This does not apply. Why? Why does it not apply?
This is any of y'all's.
Go ahead.
I can't see that.
Ladies, we'll come back to that after the end of the period. I'll take care of it at the end of the period. All right, thank you. All right, so why did this not work again? We don't have that equal sign there, so it doesn't work, okay? Make sense?
Yes.
All right, beautiful, we got it. Which graph do you think represents the solution to each of the inequalities? If I have, let's talk about this as a group. If I have X is greater than or equal to Y, and X is greater than Y, talk about that for a few minutes, and give me the answer to those questions. Are we ready?
Equal.
That's what I would do. That's what I would do. All right,
We're ready.
now, what gives it away? Raise your hand. David?
The line.
The line does. So as we highlighted earlier, if you have a greater than or equal to sign, that equal to indicates what about our line? It's always gonna be solid in it. So that goes with this, right?
Yes.
No equal to here, so this goes together. Very good. Now, here's a graph that represents solutions to the equation x minus y is equal to 5. X minus y is equal to 5. And we can see here that we have an intercept of -5, the y, x-intercept is +5, okay? Sketch 4 quick graphs representing the solutions to each of these inequalities. So this exercise I'd like for you to do independently. And then once you work on them independently, get with your partners and see what everyone came up with, okay? After we do that, then I want you to share with me your answers. So think independently on these problems. Think independently. After that, work with your group, see what you come up with, and then we'll talk about it. So that's what you have over as a group together? Okay. Sounds good.
That's what we got
Sounds
for the
good.
ALD.
Thank you. That's good. Y'all talked about it together as a group? That's your answers?
Not yet.
Okay. Work on that, and then we'll talk together as a whole. Remember, everybody, as you answer these, what's your first step that you're gonna do? You're gonna put these in what type of format?
Why is MX plus B?
Y is equal to MS plus B format. Perfect. That's what we're gonna do.
That's what we wanna do.
Every time,
Every time.
all day.
Again.
Every time.
All right, my friends, let's look at these graphs. Let's look at these graphs. We have 4 quick graphs representing the solution to each of these inequalities. All right? So as you take a look at these graphs, I don't want to give the answers away, right? All right, so let's look at the first one. What is our graph going to look like on our first equation? What is that in y is equal to MS plus B format?
It is y is greater than x minus 5.
All right, because of the fact that we moved over the x, okay, we moved the x over, that gives us a negative x plus 5. And so here's the point, Lily said greater than. Why is it greater than?
Because you divide by negative.
You divide by a -1, so that makes it, you have to move it. So therefore, you come up with y is, we flip the sign, and then we have, x minus 5. All right? X minus 5. So y is greater than or equal to x minus 5? There's no equal to, yeah, sorry. Getting too excited. All right, so y is greater than x minus 5. So what is my graph, what would my graph look like roughly?
So you're gonna go y-intercept is -5.
Y-intercept's -5. All right, and then we're using slope rise over run, so 1/1. So if we're going 1/1, which way are we going? We're going back this way, right?
Yes.
Okay. So we're going back that way. What do we look like? Say this is -1, -2, -3, -4. So 1/1, we're pretty much gonna be right here. What's your graph look like? Did it hit the 5?
Yes.
It does hit the 5. So we should, just like the other portion, we're gonna look at it this way. Okay. Now, greater than, so what does that mean for our shading? We're gonna be shading up.
On a dotted line.
It's gonna be a dotted line. I keep going back to equal to, I'm sorry. I keep going back to equals to.
Come on, Mr.
But
Allen.
yeah, all you have to do is erase a little,
I know. I keep going back to equals to, I don't know why.
Is that his?
Maybe that's what it is. Now,
Your mom's?
I know it's cricket Abigail. Now, let's go to our second one. What do we end up here with our second one? Anybody like to do the graph for me? What are we looking like? Lily? Go ahead. Very good. Now, it says less up there, Lily. Why did you shade above?
Cause there's a negative one, so you change the sign.
Very good. It's a negative y, so we have to change the sign. And we have an equal to this time that I keep trying to make up there, a equal to. Now we got equal to, so we have a solid line. Very good. Now, as we finish this lesson, let's look at, our practice problem as we finish. Our practice problems are located on the next page. So page, all right, 322. I'd like for you to do practice problem number 1. Once we finish practice problem number 1, we can pack up for today, okay? You guys did a great job. So first step, always put it in y is equal to ms plus b form. When we get into y is equal to ms plus b form, that's gonna give us our intercept. That's gonna give us our slope that we can work with. And once we have those two things, our intercept and our slope, then we're able to make our line and shade it in the right region. One more point. With the lines being shaded in the right region, what do we highlight about the regions? When the region is shaded, what does that mean? No solutions, or all the solutions are in that region? The solutions are in the region. And then what if the line has dots in it? Will that line include the solution? No, it will not. Very good. That's what you need. All right, so what we'll do tomorrow, we'll review this practice problem. We got 1 minute left. Go ahead and gather your things. Have a great weekend, okay?
Okay.